Hello and welcome to my session on data communication fundamentals. We will learn basic concepts of data communication in this session. Let's find out what we got. We have the contents here we have the contents like protocols, standards, ISO model, signals, wireless communication, like that. We have to let's go to the first topic. Protocols. Protocol is a set of rules which governs the data communication. So, if two entities, sender and receiver, uh, started a communication, so sender and receiver must have to follow a protocol. If not, the same protocol must be followed. If not, that communication will not be happen. So, data communication protocol is one of the most fundamental requirements. So there are two types of protocols. One is a standard protocol, the other one is a proprietary protocol. So in standard protocols, they are common for multiple devices. So these are free and we can use for multiple devices. Not these are not made by uh, or developed by any uh, vendor. So these are not vendor specific. So there are the examples you can see: SMTP, SSH, IP, like that. Those are, we can use all those protocols without any licenses. So proprietary protocols. What are the proprietary protocols? Proprietary protocols are, like I said, proprietary protocols are the vendor specific protocols. So they are developed by specific organizations. These protocols can be used by the devices which have the appropriate license from the protocol owned by that organization. So proprietary protocol, we cannot use it freely. It's like iMessage, Apple Talk, EAGR, like that. There are so many proprietary protocols here. Next, we are going to standards. Standards provide specific guidelines for product manufacturers and service providers to ensure that an interconnectivity in the market and international communications, and it also helps to maintain competitiveness on the market, and it provides national and international interoperability of communication process. So standards will help clients to clients can decide whether to buy this product, this brand of product, or the other brand of product by comparing the standards. So that's what standards is all about. And next, there are types of standards. One is de facto standard and other one is de jure. So in de facto, standards that have not been approved by an organized body but have been adopted standards through widespread use. So so those can which those standards were not approved by an organized body. So the other one, de jure, are approved by an organized body, and it says de jure standard. And the other one, the other slide, we see standard organizations. So there are so many standard organizations mainly we are focusing on. So one is IEEE standards. IEEE is the most widely used uh, standards for wireless communication. So for wireless communications, they have made 802 standard for wireless communication. So there are few working groups assigned for each kind of wireless communications. WLAN, PAN, like that, WPAN, like that. There are so many working groups assigned for each kind of data communication in the IEEE. And ETSI is a European Telecommunication Standard Institute. So it's working in the Europe and have product standard specifications for various broadband wireless access technologies. So and the International Organization for Standardization, we call that ISO. So ISO provides us the ISO OSI model. So the model name is OSI, but the organization is ISO. So ISO is also one of the main organizational bodies. And Federal Communications Commission, FCC, it's governed in USA, and it is for radio frequency systems in US, and CTIA, and we call that Cellular Telecommunications and Internet Association organization. So and it's mainly focuses on wireless communication and mobile communication. Let's go to the next slide. So this is the ISO OSI model. OSI is the model name. Again, I am saying OSI is the model name, and ISO is the organization name. So ISO OSI model provides us a layered architecture to communicate to show us the communication between data communication paths. So these layers are a conceptual design, not the obvious practical design, but it's a conceptual design. So let's find out what are the main things in each layer. So in these 7 layers, we started from the bottom. It's physical layer. Physical layer is considered as the interface with the communications hardware and transmission medium. So it transmit raw bit data to the transmission medium and sends to another device. So it converts bits and bytes to electronic signal, and converts again electronic signal to bits and bytes, and that is the main part of physical layer. And in data link layer, uh, there are two main methods. We will talk about it later: error control and flow control. And we know in each layer we are adding a header, and in data link layer we are adding header and a trailer too. So in data link layer, it's used to transmission of frames containing data or control information. And in network layer, it's effective where the end-to-end path consists of series of data links either within one subnetwork, it called a WAN, or a collection of subnetworks. So network layer provides routing and relaying over the subnetworks. So in transport layer, we consider as the heart of the ISO OSI model, provides a reliable end-to-end transfer of data between two communicating systems. It provides service independent of the underlying subnetworks. It acts as the separator between the end system related protocols, we call that internetworking, and the subnetwork related protocol, we call that interconnection. So that is the fourth layer we were talking about. The session layer, the fifth layer we are talking about. Session layer mainly manages the sessions, control the sessions, remove the sessions, terminating the sessions, establishment, the creation of the session, those things are governed by session layer. And next one is the presentation layer, and it provides common transfer syntaxes and resolves differences in data representation in end systems. And the final layer, the application layer, the graphical user interface is in the application layer. So it provides the services for user application processes, and it also provides the service of file transfer methods, remote terminal accesses, messaging, remote job entry, like that, security. So encryptions, those are in application layer. So each and every layer has protocols defined, and those protocols can the standard protocols are defined in each and every layer, except for obviously physical layer doesn't have protocols. And the other one, other design or a layered architecture is the TCP IP model. TCP IP model is designed as 4 layers, and those 4 layers are, if you can see the screen, you can see the 4 layers called, first is the network interface layer. It combines the work of data link layer and physical layer in ISOSM model, and it defines how the data should be sent through the network, and it is responsible for the transmission of the data between two devices in the same network. This is equal to the combination of physical and data link layer. And in OSM model, in internet is responsible for sending packets from source to destination with the help of the other networks. So the source and the destination can be on separate networks, so it can communicate with separate networks in internet layer and send the packets. So that is network layer. The next one is transport layer. It's responsible for sending process to process messages. We use port for process, like that. Process to process messages are sending because of transport layer. We have that famous protocols in transport layer, TCP layer and UDP layer, transmission control protocol, user datagram protocol, and there is another protocol called SCTP, stream control transmission protocol, which these protocols help to communicate between specific application inside the host. It's in application level. So, and the next layer is application. This is the layer equal to application, presentation and session layers in OSM model. So application interface, it application interface software applications to implement a communicating component using protocols like SMTP. We know that simple mail transfer protocol, and HTTP, hypertext transfer protocol, largely used in web browsing, and SNMP, simple network management protocol. So the main functionalities of application layer is allows users to log on to remote host, email and file transfer services, and helps to identify communication partners, determining resource availability and synchronization communication. So those are the main things we are considering on TCP/IP model. And next we can see both models together, OSI model and TCP/IP model. So in OSI reference model there are 7 layers, TCP/IP model 4 layers, but there are lots of common things in both layers. So both models are based on layered architecture, both are logical models, and both define standards for networking. Both models simplify troubleshooting process by dividing complex functions into simpler components. So in both models, protocols are defined in layer-wise manner. So protocols are not defined in uh, two layer. One protocol cannot be in two layers. It's in layer-wise manner. So next, uh, what I want to say is signals. About signals. Signals, we know basically there are two main signals: analog signal and digital signal. You can see the diagram here. So in analog signal, uh, we can see it's a continuous signal. It has infinite number of levels in two specific time gaps, time period. So the next signal we can identify is digital signal. Digital signal represent data as a sequence of discrete values. So digital signal can take only one value from a finite set of possible values at a given time. So there are only two values, 0 and 1, and we can give 1 for 5 volts, 0 for 0 volts. Like that, a digital signal can be represented. And the next one is main main concept in data communication methods. It is modulation. So it is a technique that used to send information by modifying the characteristics of a basic electromagnetic signal. So the basic signal, we call that the carrier signal. So we modify those modify some characteristics of that carrier signal. So the carrier signals have amplitude, frequency, and phase, as you can see. So in modulation mainly focus on converting a low frequency analog signal to a high frequency analog signal in analog communication. In digital signal communication, uh, a, a digital signal to an analog signal, we convert the digital to an analog signal. So so these are two main categories of that. So we can go to, yeah, in analog modulation signal is analog. So there are three types. Amplitude modulation, we can amplifies the we can modify the amplitude, frequency, and phase in analog signal. So we normally call AM, FM, and PM. In digital modulation signal is digital, and we convert it to analog. So it's ASK, FSK, and PSK: amplitude shift keying, phase shift keying, and frequency shift keying. In phase shift keying, phase is phase we call 90 degrees, 80 degrees, 180 degrees. Those are the phases. So in phase shift key, we divide phase shift keying process into few more processes, like For 2 phases, it's bipolar phase shift key. For 4 phases is quadruple phase shift key. For 8 phases is 8 PSK. 16 phases is 16 PSK. Likewise, for phase shift key, according to the number of phases, as example, BPSK has 0 and 180 degree. Then it converts into uh, uh, two it has two possible values. Like that, we can the modulation can be happen. And there are in wireless communication technologies, there are few impairments. The basic impairment is noise. The first impairment is noise. There are 3 impairments: noise, attenuation, and distortion. In noise, it is we call noise is an unwanted signal. So it occurs for the because of random movement of electrons in transmission media. Uh, the noise is also called as thermal noise and white noise. So we cannot fully fully remove the noise from any bandwidth. So in each and every bandwidth has noise in communication system. So there is no practical way to eliminate it. Anyway, we can reduce the noise by using modulation techniques. So noise can be reduced from the techniques we have talked about before, modulation techniques. So in those are the things happen in wireless communication. But in wired communication, in copper conductors, there are crosstalk and impulse noise. So those are the noise factors. And attenuation, it is a reduction of strength of the signal when it travels through the media. So in if we know in copper conductors, this happens due to heat dissipation. And in radio transmission, in wireless radio transmission, this happens due to atmospheric absorption by water. Water, not only water, it's a vapor and dust too. So in fiber optics, this happen due to scattering, absorption, and bending. So it is the reduction of strength. So in distortion, the message sent by the sender is replaced with a different interpretation as a receiver reconstructs the meaning of the message. So you can see the diagram, the second diagram, the second signal is shifted from the first signal. The first diagram, second signal, the phase is shifted. And so then the third signal also, when the phase is shifted, the signal received at the receiver's end will be totally different. So this is what we call distortion. So we are now moving on to the PCM, is pulse code modulation process. So pulse code modulation is the technique used to convert analog signal to a digital signal. This is the main technique we are using to convert analog signal to a digital signal. So it has 3 subcomponents: sampling and quantizing and encoding. So in sampling, samples the analog signal to specific time gaps. So we sampling it. So in quantizing, samples taken from above are divided to many discrete levels. Each of the samples are numbered according to their corresponding level. So in encoding, after quantizing, each of the level is represented in zeros and ones as a bit pattern. So multiplexing, there are 2 types of multiplexing. One is frequency division multiplexing. It is mainly for analog signals. And the time division multiplexing, mainly for digital signals. And there is another one called orthogonal uh, multiplexing. uh, so we divide time division multiplexing to bandwidth to multiple time durations. In FDM we divide bandwidth to multiple frequency divisions. So it's OFDM, you can see in the diagram, it can save lots of bandwidth. There are conventional frequency division frequencies, and we combine it without affecting each other. So we combine it effectively and we can save lots of bandwidth here. So channelization is a simple access method in which available bandwidth of a link is shared in time, frequency, or through code. So in this is the multiple access method. uh, so the available bandwidth is shared in time, frequency, and code. So we can see TDMA, time division multiple access, and FDMA, frequency division multiple access, and CDMA, code division multiple access. So CDMA uh, differs from FDMA because only one channel occupies the entire bandwidth of the link. So it differs from TDMA because all stations can send data simultaneously. There is no time sharing in CDMA. So we use CDMA very commonly. So in data link layer, the main component of data link layer is error control. One of the main components. So the main paths are error detection and error correction. We have forward error correction when the receiver uses the error correcting code to correct the errors, and the backward error correction, so the receiver requests the sender to retransmit the frame. So that we call error correction methods. So there are error detection methods too. So block coding is mainly used for both error controlling, error detection, and error correcting. So mainly in single bit errors, single bit is 1 bit error. So the burst bit error is more than 1 bit errors. So let's see, block coding. Block coding is a mechanism to detect the error and correct the error. So redundant bits are used here. So the redundant bit technology in block coding, there's a code word. So there's a data word we add, that is what the sender sends to the receiver, and we in the sending part, sender add redundant bits, and it creates the code word and send to receiver. Then receiver accordingly check if there is a error by checking his or her possible values to the code word. So the data word is converted in a code word in block coding process. Yeah. So these are the error detection and error correction graphs. So cyclic code is having main thing is cyclic code having code words for shifted. There are shifted code words. You can see triple 10 is a code word, and the shifted code word, the 0 in the rightmost face to the leftmost face, and it is also a code word. So the possible code words are increased here in cyclic code. So checksum is used. Checksum is also error correction method. This is used in more than single bit errors. So to support the error control method, we have flow control. So when the receiver asks for giving an acknowledgement whether to send the message again, Then sender have a buffer called transmit buffer, and it stores the buffer. In the buffer it stores the previous signal and then sends when the receiver wants it. And the receive buffer also, when you need to check from receiver's end, and it can also be used the receiver buffer. Receiver when before check in the checking process from the receive buffer stores the signal until the detection is over. So flow control is a more of a supporting method to the error control. So there are two layers inside the data link layer. We call that MAC layer and the LLC layer. So the MAC layer is media control, the media access, mainly controls the operation of access methods, and it also there are a few more responsibilities in MAC layer, encapsulating the frames to make it suitable for the transmission via the physical medium, and it determines the channel access methods for transmission, collision resolution, initiating retransmission in case of a collision. So collision detection, collision avoidance also main parts of main protocols of MAC layer, and it generate frame check sequences and reduce the retransmission errors. And in LLC layer, we call logical link layer. So the second layer in the MAC layer, the second sub layer in the MAC layer, so mainly created provide the flow control and error control here, and multiplexes protocols over the MAC layer while transmitting, and likewise demultiplex the protocols while receiving. So that is done by LLC layer. So hop to hop flow and control, error controlling, assigning frame sequence numbers, which not to conflict the other frames, you assign frame sequence numbers. So tracking acknowledgement, the acknowledgement tracking is there, and providing multi-point communications over computer networks. So there is IEEE 802.3 MAC layer format, and this is the MAC layer frame format, and we can see the preamble, the first part is preamble, and the SFD, destination address and source address, and the length, data and CRC check. So preamble, this indicates the starting of the frame and allows sender and receiver establish this bit synchronization. Start of frame delimiter SFD is always set to a 1 value that indicates upcoming bits are started from starting of the frame. So this is the start of the frame, so that value, from that value we can identify that the destination address. So contains the MAC address of the machine for which data is destined. So the destination address is there, and the source address again in 6-byte field contains the MAC address of the source machine. And source address is always an individual address. The least significant bit of first byte is always 0 because of the unicast addressing. The length is only a 2-byte field, so 16 bits, which indicates the length of the entire Ethernet frame. Ethernet frame is, yes. So the data field, this is the place where actual data is inserted, known as payload. Both IP header and data will be inserted here. Internet protocol is used over Ethernet. Maximum data present may be as long as 1500 bytes. So data is here, and LLC layer is also in the data field. So cyclic redundancy check is a 4-byte field, field contains 32 bits hash code of data generated over the destination address. So address length and data field. If the checksum computed by destination is not the same as sent checksum value, data received is corrupted. So we can identify the cyclic redundancy check whether the data is corrupted or not here. And the last concept here is IEEE 802.11 architecture. We call that Wi-Fi or WLAN architecture. In WLAN architecture, there are a few components we have to identify: the station, access point, BSS, and ESS. The stations are connected to access point in a so it creates a BSS. So BSS is basic service station, base station, BBS. Basic service set is the BSS. So BSS includes access point and the stations. So it creates a BSS, and then there are more than one BSSs. So those are interconnected by a distributed system, and then creates lots of BSSs integrated by a distribution system, and that creates a ESS, an extended service set. So likewise, the WLAN connection is we can find that in IEEE 802.11 architecture. I hope you learn the basic concepts in data communication. So thank you very much everyone for watching. Thank you.